Hello, this is Lisa Rutter. I wanted to thank everybody for joining us tonight. I am the president of the PDA chapter for our Pacific Northwest, and we are having a little bit of difficulty with our presenter getting logged on, but he is working on that. And while we're waiting, I was going to have Spencer Johnson, our sponsor committee chair, introduce our sponsors for our chapter. And we have a special sponsor who's going to do a small presentation as well for about 5 minutes. So we will proceed with that.
Spencer. Hi, everyone. Yeah, my name is Spencer Johnson. I work at Bristol Myers Squibb, and as Lisa said, I'm the head of the sponsorship committee. And just first off, I want to give a big thank you to our sponsors. It's been a very different year than we thought it was going to be, but they've been great. Pace Analytical and BioPharmaQuip, and Margaret from BioPharmaQuip has a little presentation. Margaret, I think I've unmuted you if you want to say hello.
Okay. Can you hear me?
Yes, we can. And Lisa, if you can pull up her slide.
So I am sharing the screen.
Yep.
Do you guys see it?
It's perfect.
Okay.
Okay, so my name is Margaret Stava. I started BioPharmaQuip about a year ago, so I'm a woman-owned business. I've been in the industry for many years. I'm a manufacturer's rep representing 6 quality factories, that some of whom I've had relationships with for many years, but I saw a need for a focus on CGMP, having moved over from the lab side. And I will say I'm a poster child for PDA, because it is the knowledge that I've gained from attending these sessions that I feel has given me the strength and saw backing to move into working with CGMP processes and equipment. And so the different types of equipment that I represent are ESCO isolators, downflow booths. I have microbial air samplers. I do CGMP walk-in rooms. So we guarantee volumetric uniformity, very important. Stability chambers, controlled rate freeze thaw, container closure integrity equipment, and I have a line of adherent cell bioreactors. And so I really miss seeing everybody in person, and I'm glad that we can get together this way virtually.
Awesome.
And my contact information is on the slide.
Great. Thank you, Margaret.
Thank you.
Lisa, I'll hand it back over to you.
Okay, I'm still waiting. So I'll introduce Joseph. I'll talk a little bit about him and see if we can get him online. So please be patient, everybody. Joseph Longworth works for Jubilant Hollister Steer. He has a degree in biotechnology from Eastern Washington University and has been with JHS for about 9 years. He has held positions in validation, QA, and engineering, and has led about 30 compliance and oversight team members in preventing deviations via effective shop floor presence and investigations. We actually held a PDA meeting last fall and got to know Joseph a little bit and introduced us to this cause effect analysis tool that we have now adopted at my facility. So we're really excited to have him share more about his experience with this. His team implemented investigation workflow for deviations, which has been recognized as best in class by regulated authorities, both US, European Union, Russia, Japan, Korea, and Brazil. He currently has transitioned to a senior engineering manager with responsibility for leading engineering and internal project management teams. So that's a little bit about Joseph. We will wait a few minutes to see if we can get him online. So hold on one moment.
Okay, apologies for the delay. I'm gonna send the files over to my phone and present off my phone.
Okay.
So just another minute and I'll be able to download it and get going. Okay, so probably can just everyone see my screen as it is. So we'll go over to PowerPoint. Can everybody see that?
Yes.
What happens if I hit play? Well, la-di-da.
Looks like it's working.
Exciting. Oh man, is my camera on? Can you guys see me?
I can't,
We can't see you, but we can see your presentation.
which is,
Well, I think we'll just take what we can get, even
Yep.
though I am looking pretty fresh today. Okay. Whew. Well, that was a little exercise in root cause analysis right there. We know exactly what's wrong. I just have no authority to fix it.
I already gave your intro, Joseph, so you're good to go.
Sweet. So we'll just roll right in then. Yeah, so today we're going to talk about deviation management through cause and effect analysis. And I know that this is a super riveting topic to talk about, but I'm going to warn you guys of a couple things. One is I'm super passionate about this topic, so I will try not to go and speak too quickly, but please slow me down if you have to. And the other thing is I have served as a table host for regulatory audits for 5 years, and we average like 6 regulatory agencies a year. So I'm super comfortable with silence. If I ask a question, you probably won't get me to talk first. So just beware. If I ask for some engagement, we can all sit quietly together until we jump in. But hopefully I give you a reason to engage. So the agenda for today is I'll do just a super brief introduction since Lisa already did that. And then I'll give you my provocative and engaging thesis statement. And then we'll talk about hurdles, runners, races, finish lines, and exercise. And it will make sense later how that applies to cause and effect diagrams. Yeah, so I've been in pharma for 9 years. I helped kind of pioneer our deviation management system with help from some of our big pharma clients and just other individuals that have helped me along the way. And the result is that we've created a deviation management system that is well regarded as best in class. And we are able to get to root cause in our investigation system about 95 to 98% of the time. Our reoccurrence rate's very low. And we're able to close even I think the most complicated deviation we closed in under 30 days. We had a legitimate media fill failure, and we still closed that. I think we missed 30 days. I think we got it in 32. But the system is quite quick and very rigorous and shows very well. And I would love to share with the whole world what we've learned, so you guys don't have to learn through the pain that we did. Yeah, and I'm just a couple things about me. I went to Eastern Washington University. I did my degree in biotech there. And I am a huge problem-solving junkie, so this is why I get so excited about it. So here's my provocative and engaging thesis statement, and I would like to hear from you guys. I wrote it this way to hopefully stir up some reaction, but I would say that executing a world-class investigation system or deviation management system is very similar to running a hurdle race, in that the best systems will barely meet the minimum requirement as rapidly as is possible. Does that naturally sit well with everybody? Does anybody say, I don't like thinking about a deviation management system as barely adequate at high speed?
I think for our attendees here, if you want to respond to that, you can hop onto the chat and type your reactions, and then I'd be happy to read those out. You're not allowed to unmute yourself.
Oh, shoot.
Yeah, we have everybody muted, Joseph. We can monitor questions and things like that and provide them to you, but yeah, they're all muted.
Well, sweet. Let's see if we can get a question or two, or at least a gut reaction.
Joe fully agrees. Virginia would like you to define bare minimum.
Virginia is sharp. That is the crux. So let's talk about it. So if we're going to run with this hurdling analogy, which I recommend we do, the hurdle itself is super important, right? So if you pick a hurdle and you're running a hurdle race and you are, let's say you're in an NCAA race and your hurdles are not high enough, then your race is not going to count. If you're running in the Olympics and you're trying to set a world record and your hurdles aren't high enough, then nobody cares about your effort. So when we talk about investigations using a hurdle metaphor, we have to understand that an intrinsic part of that metaphor that can't be separated out is this concept of how high are the hurdles and where exactly are they? And there is some mastery that's required there. So if we don't have our deviation system or investigation system clear the right objective or meet the right requirements, then it doesn't matter how hard we work, and it doesn't matter what we learn or what we find, our work won't be good enough. Now, there are some firm regulatory requirements for deviation management, and I don't know kind of the background or the cross-section of who's on the WebEx. But for those that are just getting introduced to deviation management or investigation, I think the easiest regulatory references to read and understand are 21 CFR 211-192 that effectively says you have to follow written procedures, and anytime you don't, you have to explain and investigate what happened and what is the impact. And then also in kind of more thorough English is Udrlex Volume 4, Chapter 1, Section 1.4, Subpoint 14, which is a lot more expansive on what are the elements of a good investigation from the European Medicines Agency perspective. And they require pretty explicitly that either you find root cause or you find contributory causes, and all contributory causes that you find, you should attempt to correct them when reasonable, and that you should also follow up and look for effectiveness on your corrections. And that's all well and good. And we can definitely work under the understanding that a deviation system is required by regulations, and we don't really have a choice as to whether or not we engage in that regulatory burden. It is part of what it is, part of the cost of doing business in pharma. I would definitely question if that is the approach your firm is taking. I would suggest that it might be time to dig into the question of why on earth do the regulators require robust investigations? So the regulations are there for a reason. There's always a comment period. The industry always gets a chance to weigh in and provide input, and these investigation requirements persist. And then even in industries that don't have such tight regulations, there are phenomenally talented investigators working in those industries. So I would argue that while we could say that we're going to engage in investigating well because there's a regulatory obligation, I would also say that if that is the only reason we're investigating well, it's going to be very challenging to move into a world-class position if the firm that you're working for is doing it out of compliance. At our firm, I would say at one point in time we were doing this out of compliance, and we've shifted from doing it out of compliance to doing it because it really matters, because I think this is way more compelling. So if you're doing it for the regulations, it's super boring, and at best it's compliant. We really investigate to make sure that the people that we're serving are safe. Our internal stakeholders, our teams in the plant, and our patients out in the field. And we also need our investigation systems to make sure that as much safe medicine makes it to market as possible. And this is part of where barely clearing the hurdle is really important. It is very easy to deal with most deviations by rejecting a batch. It does not take a ton of skill to throw lots away. A really good investigation system is going to do a much more rigorous job of providing granular evidence that can relate the failures that you've experienced to the factors of the medication that you're making to determine whether or not that is safe for release. This is something that our company's gotten quite skilled at, and it's not. These are not the kinds of things that you do just based on sound scientific rationale. It's always a part, but you really need a mechanism to get very good direct evidence, because we don't really roll the dice with patients in the field, right? I added these pictures here. This is one of my best friends and his family. He got diagnosed with pretty serious brain cancer a couple of years ago. I guess 1 year ago, literally last week. He was visiting some family in Memphis and had a seizure out of nowhere and wound up having to get emergency brain surgery in Memphis and having to stay there for a couple of weeks before they could transfer his care over to Seattle. And we make brain imaging agents at our plant that aid surgeons at identifying where tumors are and identifying those with very clear resolution so that we can excise the minimum portion of a healthy brain. And Josh is doing great. Thank God for the cancer teams over in Seattle. They're absolutely amazing at the hutch. And he has anaplastic astrocytoma, and it's effectively not showing up on any scans right now. So things are looking really good. And he still absolutely demolishes me every single time we go mountain biking together. So I get my butt kicked by a cancer boy every time we ride bikes. So that's super cool. Just kidding. Hopefully that didn't offend anybody. Doing this muted is tough, but this is why I'm
Hey,
super
Joseph,
Yeah.
just to interrupt, I did unmute all our attendees, so you guys have the ability to interrupt and stop. So if you want to ask a question, you should be able to do that.
Awesome. Yeah, please speak up so I'm not just talking into the void, because it's weird, especially on my phone. Yeah, I think this is a way better reason to investigate. I think it's important that we investigate very diligently so that our medicines are really safe, so that when people like Josh need emergency surgery, he has access to safe medicine. I think it's really important that we close deviations quickly so that his supply of medicine isn't interrupted. I think it's really important that we release all the medicine that we can prove is safe so that the cost that Josh pays for his medicine does not increase needlessly, because we don't have the mechanisms to do the hard work to determine what is safe and unsafe. So this is what gets me really fired up and super passionate. We have the luxury of working in an industry where we directly impact the lives of people that maybe you even know. So really there's four whys to why should we investigate rigorously in my perspective. We value preventing problems from getting worse. So when something has gone wrong, as an organization, I can speak for my company, Jubilant Hollister Steer, we really value controlling that fire from spreading immediately. We want to make sure that we don't disrupt the supply of essential medicines in other lines, other lots made from similar RMs. So we have mechanisms to very rapidly, within one day, identify and contain a potential problem. We investigate really rigorously because we value delighted stakeholders. We really value that when people participate in a failure investigation, they leave enriched. They find it to be a fun and engaging exercise, even though we're looking a big failure right in the face. It is very fun and rewarding to solve those problems collaboratively if you have the right culture, which takes a lot of energy and effort to create. I did not inherit a culture like that when I started in my role in quality, but we definitely have created it over the last few years, where it's not uncommon to walk by a conference room and hear a lot of laughing and then just assume that that's a root cause analysis meeting happening. We value understanding the causal chain of failure with good enough resolution to prove that we can break it, not just to be pretty sure that we can break it or create a rationale package that says we can break it. We can demonstrate that we can break it. And we value solving problems to the degree that we accept the risk left after our action is taken. We don't solve every single problem. We solve all of the problems that we find worth solving. And if we find problems that pop up in our deviation system and we find through rigorous evaluation, and these are actually really thick deviations to read because it's a big burden of evidence, but if we can prove that that type of failure doesn't actually matter, we will increase our design space to accommodate that outcome, and we'll trap it or deal with it procedurally or just accept it, because if it truly doesn't matter and we can collect the evidence, then we don't need to spend energy and resources controlling that. So I put those things in order, in that order, for a reason. So stop additional harm, delight your stakeholders, understand your causal chain, and then break the causal chain. I believe that that is actually the order of importance when you are actively working on an investigation. What do you guys think? Would you agree that that is the order that you would care about those things, or that you would engage in those points, or would you propose a different order or prioritization?
Joseph, can you hear me?
Yeah.
Okay, so this is Virginia. Why do you put delight stakeholders above understanding the causal chain?
Yeah. Anyone else have that question? Okay. So one of the things we learned as we were going through a culture change is if that people are not cared for and they are not educated, and we didn't care about their experience in the investigation process, at best we could get the amount of effort that someone has to give us to not get fired, which is probably no more than like 30 or 40% of the effort that they can bring to the table. If we make it really important, more important than understanding the causal chain, that we run the investigation in a respectful and engaging way, then we can access 70 to 100% of people's discretionary effort. People actually really like solving problems when they feel safe doing it, and when they have a fun time doing it, and when they feel like they're supported in doing it. So what we found was number 3 actually happens on accident if you do number 2 really well. If you shoot for number 3 and you're trying to make sure that at all costs we're going to understand the chain of failure, you're actually going to fail to get there more often because the people that have the information that you need are too afraid to give it to you. Does that make sense?
How long did that culture change take you guys?
So with that is a loaded question.
Okay.
So in some ways, we're very much still in it. In other ways, effectively in root cause meetings, we got there in about 2 months. So the way we got there with the root cause meetings was we started to make sure that we're talking to key technicians, not their supervisor, not their specialist, but the actual techs on the floor in every root cause meeting. And that we spent a lot of energy in establishing a blame-free environment with them. And we actually went and started changing some of the language that we use. We don't say who anymore, and we don't say why anymore in investigations. And that was really, really important in making stakeholders feel safe, because if we're not asking who and we're not asking why, then we're not looking for stories and we're not looking for blame. We're looking for facts and we're looking for action. So we say what and how a lot. We don't say who or why anymore. So in some ways on the root cause teams, that change is already well solidified. Folks that don't have as much interface with the root cause process, we're permeating through the rest of the plant by osmosis. So kind of our culture change, it's actually really awesome. Our blame-free culture started in root cause teams and is now permeating throughout the entire rest of the organization as people understand the benefit of not blaming people for making reasonable mistakes, even unreasonable mistakes, right? Who knows what's going on in your head and if you're in cognitive overload. So something that looks completely flagrant, completely unreasonable, if you really take the time and you have the right tools to get into the causal chain, I have not yet found a bad actor. I have not yet found a disengaged worker. I have found a lot of people that are just people doing really hard work with a varying degree of chaos around them. Does that make sense? Or does that answer your question?
Yes, thank you.
Sweet. So that's the hurdle. That's the why. Why do we clear these hurdles? So let's talk about how we clear the hurdles. So at JHS, we clear the hurdles with our runners. So our runners are formally trained principal investigators. So we used to have, gosh, I'm going to get my dates mixed up, but I want to say in 2017 we had about 500 investigations in the plant, and we had 140 people that wrote them. And what we learned was it's really, really hard to teach 140 people how to do a thorough investigation. So we decided as an organization to nucleate that skill set into one team. So we created a primary investigation team. And I actually was able to, I made the pitch to do it, and I was actually able to get operations to give me 6 of their full-time headcount into the quality unit, which I think is about the most crazy and impossible thing that can happen in a drug company, for operations to give quality their headcount. And we did it because we created a data set that demonstrated that they were already investing about 14 full-time people's worth of energy in investigating really badly. And if I took 6, I could meet the whole need really well with half the amount of labor they were already committing. And for some reason, they believed my data set. And we actually wind up proving that out to be true. And the supervision, it was almost like a double win, because when the supervisors got to stop running investigations, which they didn't like doing, and they weren't really skilled at doing, then what do they do with all that time? They supervise their team. And because they supervise their team more closely, the performance of the team increases. So we actually had fewer deviations generated, and then the ones that did get generated, we had much, much better investigations because we had a professional team of investigators doing that work. And that was a really fun data set to kind of curate and figure out how to build. So when we talk about who is the runner in our hurdle race, you need to have someone that's trained and capable. And if you don't have them, it's not possible to do a good job. And doing a good job in investigations, it doesn't take try hard and it doesn't take natural talent. It takes mastery. It really takes somebody that loves the problem-solving process and they really want to lean in and make that a part of their identity as a worker. And the awesome thing is it's easy to recruit into the team, because who doesn't want a professional level problem solver in their organization? So we're kind of a breeding ground now in the investigation team for leadership throughout the plant. And we're starting to see that take off now, where people are coming after our investigators for promotion opportunities because they're such effective problem solvers, and we solve all of our problems collaboratively. So they have a lot of innate opportunities to demonstrate their leadership skills. So it's been a really cool thing to see the investigators really lean into that identity and take ownership of that. But you really need someone that has like PhD level professionalism in finding the right solution that is the right size for the right problem. And I would argue that almost has to be a full-time job.
Hi, Joseph. This is Brittany. I was wondering if I could ask a question for you to
For
talk
sure.
more about the data set that you collected.
Yeah, so we had piloted a professional investigator model with 3 people for a year. So I was able to actually get pure data that says if you have somebody that is only doing investigations, how many investigations a month can they do, and how many labor hours does it take? And we found that it was about 35 labor hours for a pretty complicated investigation of the investigator's time. Then we went and we actually tracked manufacturing supervisors, and we tracked their time spent in investigating. And they're just wildly inefficient because they task switch so often. So the average manufacturing supervisor spent about 95 hours for a similarly complex investigation. And some of them spent substantially more than that. It could go up to 180 hours. But the trick is they're only spending about 20 to 40% of their time on that investigation. So we would have some investigations that went for 5 months. And then when you read them, they were terrible. They didn't look like 5 months worth of work. But it's easy to judge that, and it's easy to talk trash about that investigator until you understand their day-to-day struggle, right? So when you look at a production supervisor that's managing a team with high goals and high commitment and drive that hasn't been invested in and doesn't fundamentally love investigational work, otherwise they probably would have found their way to QA. Can you really blame them? So we decided not to try to change that culture. We just leaned into that culture, and we decided, let's take the path of letting people do what they're good at and separating the responsibilities instead. So that's the data set that I built, was just a direct comparison between what could be and what currently is. And then I would say the key to selling it was I got everyone to agree to my data model before I made any kind of pitch. So I presented the data that we'd collected, and I got all of our executive leadership to poke at that data model to their heart's content. And then once everybody agreed that the data set was valid and accurate, then I showed them the claims that came out of that data set, because they were pretty, it's almost hard to believe when you see it, how much efficiency you lose by having manufacturing supervisors do investigations. So I kind of knew that they would get some sticker shock and say, like, there's just no way we're spending 2 times the labor. So I think it was really essential that I had everybody buy into the data model first and make sure that everybody had those questions asked before we went to the claims that came out of that data model.
Okay, yeah, that's very interesting to hear. Thank you for sharing.
Yeah, no worries. It was a super fun meeting. It actually, when I made the pitch, it was November 1st, and the president of our company told me that on November 7th, I would have 6 more people reporting to me, and I better have a way to use them. So be careful. If you create a really nice data model and it's really exciting to people, it will make you move very, very, very fast.
Okay.
But it's a good problem to have. So there's some strategic requirements to how we inform that our investigators are going to do their job. So we are going to document in our investigations what matters and what causes any specific item to matter. So what adds value or what is evidence of importance. We're going to document that that evidence is important, and we're going to document why. We require that every investigation has to talk about the physics of the failure cascade. So there are always forces acting on objects when something goes wrong, and we require that there is at least an initial attempt to understand those forces. I will say, you don't have to understand them to solve a problem robustly. You open yourself up to a lot of really great and really strong solutions if you can figure it out. So contracting with outside labs to do like metal fatigue analysis or getting particle identification is really important to us, so that we can demonstrate that if we have like a pipe that bursts, we don't just say the pipe broke, we say The pipe broke because it was overpressured inside, and that is evidenced by this fracture pattern in the metal that has been certified by this outside lab that we qualified. And then we can get some really strong evidence. And now our investigation isn't looking into what are all the ways that a pipe can break. It is what are all the ways that there could be so much pressure inside that line that it blew that pipe apart. And we know how much pressure that is. And now you can narrow way down on how many potentials you're looking at. One of the things we require is we always require that we talk about the culture and human performance factors that allowed the physics to play out the way that they did and ultimately make it all the way to a deviation. Has anybody heard the Swiss cheese model of like process robustness?
Yes.
So if you stack a bunch of slices of Swiss cheese, all the holes align, you shoot an arrow through it, you can hit your target. In pharma, we should have some level of resilience and resistance, right? It's pretty weird if you have a licensed product that doesn't have some kind of control strategy. So we require that people engage in, or investigators engage in understanding that control strategy, but understanding how people interface with that control strategy and what are some opportunities that we're giving up that allowed that failure cascade to happen. So just as there is always a physics cascade of failure, there is always a human performance and a culture cascade of failure. We always organize our documents for an educated and uninformed reader. We're always ready to present to FDA or EMA. In our last FDA audit, I went through 175 deviations over the course of 4 days. And we had one finding because I personally made one stupid mistake and I made an assumption that I shouldn't have made. So it allows you to just go unbelievably fast. We did almost our entire site's audit through the deviation system. And honestly, I did get accused of intentional fraud at some point during that audit, which was a fun experience, but we wound up having a very good relationship after we resolved that potential fear with the auditor and I. Now we're buddies, so definitely nice to resolve those problems when you have really strong data. I got accused of hiding deviation failure modes because we had understood a process so well that caused deviations that we error trapped almost every single possible way and we proceduralized everything. But I made the mistake of, instead of telling the investigator that I had done that, I showed him a chart of how many deviations of this type did we have before a certain date and how many did he have after. He said, oh, obviously you're hiding things from me. It's like, whoa. Let me explain all the work we did to understand our process better to make failures stop happening. And then he was happy, but it was terrifying. I've never seen my boss turn that shade of purple before. One of the things that we require is that all of our findings are implemented holistically. So we don't look at just a process in a box or a batch in a box. We structurally require that all solutions are placed everywhere that they should be. And then we also don't allow stakeholder engagement to be optional. We will not do investigations if we cannot access the area where the failure happened with the people that were involved in it within 1 day. So we kind of have an internal service level agreement that has been established where manufacturing managers don't get to say no. And at first, that's how it went. They didn't get to say no, even though they really wanted to. Now they never ask to say no. They always ask, as soon as a problem happens, when is the Gemba team coming to the area? I've held it in the state it was in. So it started with a kind of compliance and we had to force it. But now, actually, if we're slow at starting Gembas, the manufacturing management has an escalation mechanism they've created to get our Gemba to start sooner, which is awesome. You want your process owners pulling on the investigation process instead of pushing back against it. So that's the hurdles and the runners. So let's talk about the race, because if you don't understand the race that you're in, you can't pick the right tactics to win it. So when I talk about the race, I'm talking about how the heck. So we talked about why and we talked about how. So let's talk about, like, what are you going to do an investigation? And there's a million tools out there to try. Every single tool has lots of pros and cons. So I just kind of want to hear a couple examples of what tools are you guys familiar with when you do failure investigations?
So I've used everything from process mapping. I've tried use fishbone analysis. I've used what's it called? I'm totally blanking on the name of it now. A comparison matrix. Is that what it's called? No. Is not analysis. And now we use the cause chart, which you introduced us to and we've implemented.
Oh, do you like it?
Yeah, we've only been using it since about March, but we are using it for an out-of-spec investigation right now, and I'm pretty confident that it detected a laboratory error that we would have missed otherwise, because we forced people to find evidence to disprove that as a cause.
Yep. Yeah, that's awesome. I'm glad you got there. I think OOS is one of the areas that cause and effect analysis just totally shines. Yeah, that's awesome. What are some pros and cons of the various tools? So I heard Fishbone. What works well about Fishbone?
It's a good brainstorming tool to get people to think about all the different areas and where different causes or potential causes could exist in those areas. But it doesn't lend super well to translating that into action or telling the
totally
story
agree.
either.
Yep. Yeah, yeah, I think you kind of hit it on the head. Is anyone doing a 5Y? Like that's their key tool is 5Y analysis. Super common.
Yep.
Yeah. What works well for you in 5Y analysis? Why do you like using it?
I don't love using it, but it is organizationally the tool that gets promoted in our basic training. So everyone is familiar with it, which makes it easy to get sign off on your investigations.
Yeah, like number one benefit of the 5Ys is super fast, right? Super fast, super easy. What are some downfalls with the 5Y?
It tends to lead you down a single path and a single path only, and that's not necessarily the only cause of your situation. So you miss things.
Yeah. Has anyone ever been surprised at how hard it is to get people to have the second Y actually be the answer to the first one?
Yes.
I find it almost like funny. Like I don't know that I've ever read a 5Y the first time where all of the questions had subsequent answers that were then answered. Like it's like, why did this happen? And it just goes off into left field so fast. And it's like number 3 and 4 aren't linked like whatsoever. I think it's interesting how hard it is for the human brain to kind of stay the course there. And we'll talk about that a little bit with cause and effect charting. So we have kind of managed and defined what we do to win our race. So I kind of share what we value. I shared the requirements on how our investigators are to work. So what we do is we always assign a primary investigator who owns the investigation process. We always use a multidisciplinary team with the operators and because we want the operators to feel very safe, and we don't want anything that's done in our quality system to be used for personnel discipline, which is kind of always an ongoing fight. We always Gemba. We actually, I'm going to be a little bit politically incorrect, so forgive me, but we always Goya. We always say, get off your ass and go to where the problem happened. So if Gemba is old in your company because you're Six Sigma to death, you can start throwing Goya around and then kind of snicker when people ask what it means. We always do a cause and effect analysis. It is the only tool we formally use now. We do not do fishbones or 5Ys anymore. It's not to say that they're disallowed. In practice, that is what has happened. Our procedures still allow us to use other tools because we're not so presumptuous to think every single problem we ever face, cause and effects can be the right way to deal with it. I will say, when I was a quality manager, I reviewed on average about 400 of these a year, and I never found a problem where it was not the best tool that we had at our disposal. Doesn't mean that there's something cooler out there that I just don't know about. And we never accept any more human error as a cause if our intent is to fix the problem. We do still have human error as a selectable cause, but it is almost synonymous with though this problem is technically a deviation, it happens so unbelievably infrequently and is so unbelievably irrelevant that we're just going to say someone made a mistake. So we're actually right now talking about, do we need a different level of deviation where we don't even have to do that? We just say like it's a stuff happens deviation, and the risk profile is such that there is no way it goes bad. But you do want to track and trend those things so you don't slowly drift out of control. So it's important to have the data and important to have the oversight. But one example was we put tray labels on bulk packed finished goods. We have about 100 packaging employees that do this task. And for the first time in 10 years, someone forgot to put a label on the tray. It has never happened before. And the person that did it is shocked that it happened to them. So, I mean, are you really going to spend a ton of, oh, and there's also 2 independent checks for labels that just hadn't happened yet. So quality on the floor was doing a random prior to the procedural check for that all the labels were there. They noticed the label was missing. So yeah, we didn't totally go to town on that. We did think about, like, can we use cameras? And the team did change their training to where now they have exactly the number of labels at their workstation for the number of trays they're going to process. So it's really obvious that there is one too few labels or one too many labels. So they did take some reasonable action. Interestingly enough, none of those were required CAPAs. It's just because the operators were really engaged in the process, they just started brainstorming reasonable things they could do in their day-to-day job that they don't require quality to force them to do, and they just started doing it. So they volunteered to change their own work practice to make themselves more resilient to that kind of failure. And that's the kind of engagement that you're really looking for in your deviation system. And that's why we have these tactics that we require. It intrinsically communicates a very deep level of respect for the ownership and the engagement of the operator. If you treat them like they're disengaged and they do stupid things, like play stupid games, get stupid prizes. If you treat people that way, then that is the performance they're going to show you. But if you treat them like you respect them and you know that they are engaged, you give them the benefit of the doubt, you assume positive intent, and you let that institutionally permeate the way you solve problems, you will be shocked at how rapidly your workforce begins to care about quality. When it's almost like investigations are now our best CGMP training tool, because now people are understanding at a really deep level why we do things the way we do and why we have the controls we have. And now they have the opportunity to take ownership in a way that they hadn't had just through their training process. Super cool to watch. So now let's talk about the finish line. So if you don't know where you are in relation where you need to be, then you're probably not going to use the right effort at the right time to get there, and you might run out of your lane and just fail the race completely. So the end goal that I would encourage you guys to drive towards, and I'm going to make a pitch here for cause and effect diagrams. The power of a cause and effect diagram is it shows you with spatial relationships the causal network of failure, because it's not ever just one cascade. Failure networks are actually infinite in all directions. I was going to build some charts on the web, but my computer's down, I can't do it. But let's just have a little bit of a thought exercise. So let's assume that I have just spilled some water on my desk. What kinds of questions would you guys ask to understand why I have spilled some water? That's my problem statement. I spilled water on my desk. What would you guys like to know if you're going to investigate that and prevent it from happening in the future?
Where did the water come from? Like, what was the container it was in?
Yep, I got a mug with no lid, and it's very narrow at the bottom and very wide at the top. So a 5 wide, right? Like, why? Why do I have that mug? I have that mug because my brother-in-law started a company on Amazon so that he could live out of his van and quit his engineering job to go climb all over the world while living in a camper van. So I tried to buy a mug to give him like a couple bucks to buy like a gallon of gas. What made me do that? I love my brother-in-law. He's awesome. He's a super nice guy. I have a really great, I'm like the luckiest person on earth when it comes to in-laws. Why is that true? I don't know. Like, I found this cool lady once when I was skiing at Bachelor, and she beat me at moguls. So I decided I would marry her because she can ski better than me and I like skiing fast. Why do I like that? I don't know. When I was 13, I had a really impactful experience on the mountain that gave me a deep-seated love of skiing. Probably that'll last until I die. Like, all of that is causal and all of that is real. The investigator's job and your tool's job is to manage the crazy and focus the investigation where the investigation should go, with the intent that you solve your problem the way you want. That is where cause and effect diagrams have a power that other tools just don't have. You can look at your entire causal network, your entire cascade, and all the interdependencies, And the power of it is you can pick what you want to fix. And if you do it right and you build it correctly, if you fix any one cause in the network, the entire network crumbles. And that failure is not possible in that way anymore. So that allows you to scale. Do we want a solution that's going to solution? There's 100 ways we could have got to this failure mode, and we want to solution all 100 of it. Yeah, so the end state that I would encourage you guys to move towards is having that cause effect diagram, because it lets you scale your solutions to it lets you scale your effort to where you think you will find a solution. It actually also works really great as a 5 why framework. So understanding how branches can come off of a causal pathway and then documenting your decision not to chase them and why you don't want to chase them is hugely powerful. It also keeps people really focused on kind of not squirreling away and drifting off where the whys no longer make sense. They don't logically follow anymore. Another great outcome from the cause and effect diagram is it allows you to have really good conversations around why you should or shouldn't invest in a solution. So I'll give you an example. So this is a real failure analysis I did in my own head, and I just recently solved this problem. So I have driven an FJ Cruiser since 2008. I took it off-road like crazy when I was single. When I got married, I don't off-road it so much. I have 2 kids now. I off-road more now with kids than without. My son loves it. I was driving in my driveway and I heard a weird thunk come from the back end of my FJ Cruiser. So my dad and my grandpa both retired from selling tools. So I have every single tool on the planet and I know how to use them. So I crawled under my car. I found that what was causing the knock, the proximal cause, the point of cause, was the rear shock bushing it had too much play when mounted on the shock mount, which is welded onto the axle. So you have a steel ring that wraps around a steel stud, and they are not supposed to have any play. The tolerances are supposed to be tight enough that it doesn't move at all, but it had worn out. The way I solutioned that problem was I sold my FJ Cruiser and I bought a brand new Chevy Colorado ZR2, which also can off-road very nicely. So I solved that problem with about like 40 grand. Is that a logical conclusion to that failure cascade for all of you? Like if I worked for you and I came to you and I said, hey, the way we're going to solve this problem is, oh my God, overkill. Would you say like, yeah,
good, not good.
Not good, right? Not good at all. But then what if I push back and I say, no, Lisa, this is the right thing to do. You don't understand. It's the right thing to do. We're going to have a super weird conversation, right? So I propose it, you push back because it's obviously insane, but I don't let go. And you know I'm a rational person. So now you're wondering, what the hell else is going on that you don't know about, right? The great thing about cause and effect diagrams is that not only are they infinite, like think of it, you start at the left and you move to the right. They're not just infinite to the right, they're infinite to the left too. So now what if I told you that for 2 years, I have known that I want to sell my FJ Cruiser and buy something else. And for 2 years, I have not found another vehicle that I would like to buy. I really value not having to do maintenance right now because I have little kids. I'd rather play with them than maintain my cars. I also value never going to a mechanic to pay for a mechanic ever because I know that I can do the work at a 1/8 of the cost. So I'm in this weird mental space all the time where I can't justify going to a mechanic, but I can't justify taking the time to fix my car. So my car is literally just breaking down. And instead of having it break down, I'd rather sell it to somebody, make as much money as I can off of it, and buy a new car with a new warranty, because what I value most is time with my family and their safety. And in that framework, the only car on the planet that I was willing to buy was a ZR2 Chevy Colorado from 2020. And 2020 not used because of COVID, the new car rebates were so steep, it was cheaper to buy new than used. Now does my decision make some sense?
Yeah.
So the great thing about a cause and effect diagram is you can start using language like, I feel like we're too far to the right on this chart. I don't understand why that serious of a solution is the right size for what you have on this chart. Oh my gosh, I've made a terrible mistake. I need to show you the 20 other factors that this solution fixes that we actually care about. And then now you have a really nice way to explore that in unemotional language where you can maintain that safe and trusting blame-free work culture. I was going to draw this chart for you guys, but unfortunately technology refuses. The other nice thing about the cause and effect diagrams is I could have built that entire chart in about 6 minutes from scratch. So once you get good at it, you can go unreasonably fast. So that is kind of the tactics end state that I would propose is what is ideal and what is best in class. If you want to be a best in class investigation team, I think from my experience, my perspective, I have yet to see a tool that can facilitate that can naturally scale in size and complexity to the appropriate level commensurate with the risk of your problem as a cause and effect diagram. It can be as big and wide as you want. It can be 4 boxes if you want. It does require that you have a really talented investigator that knows what they're doing, though. It is for sure a tool that can empower really insane waste of time. So, I mean, I've had investigators that just chased a ghost for 6 hours of meetings before I saw their chart and saw where they went. But a nice tool about the chart, a nice thing about the tool is, as a manager, I actually stopped approving deviations and I had my supervisors begin approving them. I approved their charts before they were allowed to write reports. So I could actually see their thought process, which is way more important than seeing their word choice. So it allowed me to actually multiply our approval pipeline, which was part of getting our approval rate down. I think right now we're averaging about 24 days on an investigation, regardless of size. So broadening that approval pipeline was a big deal, but you don't want to lose control of the quality of the investigation. But if the chart is really good, then you can always talk about what the words were in the report, as long as you can demonstrate you do understand the facts and the causal links. Organizationally, the finish line, if you kind of engage in this modality or this paradigm, you could be working in an organization that demonstrates a really deep commitment to solving problems to the level of risk acceptance. Every time somebody runs into a problem, they're going to independently start chasing out what they can do to make that risk go away to the level that they accept, which is really powerful. So it makes you have, we have 700 people at our site. Instead of having like 20 people that are really invested in problem solving, we have 700. So whenever somebody sees something going wrong, they have the skills now, because almost everybody has participated in a root cause analysis at least once, to start thinking about what can I do with my resources to make this problem less likely. It also causes a huge increase of ownership of the manufacturing of quality product deep and wide in the organization. There is a huge reason there is an A in QA. It's quality assurance, not quality injection, not quality by pain, not punitive quality. We're there to assure that the operations team built quality into what they do. And for us, we've talked about that forever, but really the investigation modality and the culture of trust and blame-free problem solving really catalyzed the operators taking ownership of, it's not their job to get it done in schedule, and it's not their job to get it done in quantity. Those are their jobs. They have to get it done so that we can get it to the patient in the field. It's not even that they care about their deviation metric. They care about sick people not having the medicine because they made a mistake that they could have avoided. And that is always more compelling than some deviation metric or some financial target. We're a CMO, and a lot of the products we make, we have the only API on the planet. So if we lose a batch, there's just less of that drug on Earth. If we lose a lyophilization slot, we're booked. So there's no makeup slot coming. So there's just less of that drug on the Earth. And we all take that really seriously. And now our operators even take that really seriously. And organizationally, you could be working in a blame-free, solution-oriented culture where people are never viewed as the problem, and you don't use rhetoric and you don't use work processes that would communicate contrary to that. Your entire organization could be built around the concept that people are not, they are the way actions get implemented. And I think that's a pretty amazing and fun organization to be a part of. Even when things are hard, even when you go through, like, I don't know, a social justice crisis and a health pandemic and an economic crisis simultaneously, maybe when you've just decided to take a promotion out of quality into engineering and you're not a mechanical engineer, it's pretty nice to work in a company where everybody has everybody's back and we're all trying to do the right thing together. And it made my transition way easier, made my engineers' transition way easier. And I can say with confidence now, because it's been about 4.5 months since I left the quality role, the system is stronger now than it was when I left. So this isn't a system and a paradigm that relies on heroes and relies on active managers. It is one that becomes part of your cultural DNA that will persist whether you want it to or not after a certain point. And that's all I had. I was gonna, like I said, I talked more since I knew we'd be able to build the chart, but if you are interested in the tool that we use, it is called CauseLink. It is the Sologic root cause method. It's actually a firm out of Seattle that kind of owns the license to this modality. They have not paid me to do this at all. I just really, really believe in their product. So yeah, causelink.com. I encourage you, you can get a free 30-day demo. There's really great free resources about problem solving philosophy. And they have a really great human error reduction handbook. I think it's like 12 pages with a lot of great common sense stuff. I really encourage, if you are in a company that is struggling with trying to get more objectively accurate evidence-based solutions that your company has the bandwidth to execute, that's always part of the trouble, right? Is finding what solution can we find that we have the capacity to implement. If that's a struggle you have, I would definitely reach out to these guys and get some help. Sounds like Virginia's becoming a pro too, so she's over there.
Hey, Joseph, this is Lisa. I have a question for you. So did it take a little bit, so as Virginia mentioned, and Joe's on the line too, who's in Virginia's team, did it take you guys a while? I mean, I think everyone was trained, and it seems like it takes a while just to kind of get more and more comfortable with it, and getting faster at it, I think, is probably one thing. And then I wanted your comment on that. And then my second comment is, we actually separated, so we have our investigator team that facilitates the investigations, you know, does all the writing, but then we actually use our plant QA group to be the approvers. And is it, by what you were talking about, it sounds like, were you guys the approvers on those as quality?
Yeah, so I had quality investigators that reported to me through a supervisor. So we got to the point where we had individual contributor level workers, then we had 2 leads on the team, 1 supervisor, and me. So the supervisor was able to approve non-product reject deviations, and the leads actually approved our lowest tiered deviation. We call them minors or level 3s. But the investigation team did not write level 3s. So no investigator approved work that a different investigator did. But the supervisor did approve the work that their reports did. And then I also had oversight of that. So I still popped in and reviewed them as well. And I was looking at product reject deviations. I was just starting to take that on when I left. And then our site head of quality currently does all of the product reject deviations.
Okay.
And then what was your other comment? How long did it take?
Yeah, we're still in the growing pain stages, I think, a little bit.
Totally. Yeah, it definitely took us probably a year to where it was very fluid and natural. You just run into a lot of head scratching moments where you're like, something is wrong with my chart, which is also a great advantage of it. You can tell when you've done something wrong. It feels wrong. And it stops flowing really naturally. It does take some time before you have the vocabulary and the skill to identify where is the mistake that you made.
Joe, do you have any comment on that? I mean, you guys are, you're working on one recently. I don't know do you have any comments or questions on that?
Yeah, I can comment on that if you can hear me okay.
Yeah.
It is true that we also had an OOS, and I happened to be leading it, and we started going down a rabbit hole, Joseph, like you said. And again, since we are a little newer to the process, it did take us a little longer to find it and realize it. But once we did, we were able to back out of it pretty quickly. I don't know that we would have been able to other than that, because we were really looking for a historical reason for something, and it took us a while to realize that maybe we didn't need to go back so far.
Yeah.
And the cause and effect chart really helped us with that.
Yep. Yeah, I think one of the things that I consistently provide feedback on is don't neglect the cascade that deals with the physics of what happened, or for an OS, the chemistry of what happened. It's do you have enough product understanding to really know what kind of chemistry is happening that would give us a result like this? Now, as a CMO, we oftentimes don't have insight to that level of intellectual property, but with our deeper partnerships, we will bring in our clients' actual formulation scientists to help us. And we will actually get into the original research and development paperwork to find out what do we know about how this, what kind of chemical reaction could explain what we're seeing, A. And then B, is there any known property about these molecules and the way that they are formulated that there is a risk that this chemical reaction could take place? So when you're really stumped, it is a hugely powerful tool to really get into like, what's the wet chemistry we're dealing with here?
I can add another comment. One thing that we are learning about is basically taking it really to a simpler level. The cause and effect chart we've experienced, if we keep our questions more simple, actually, we've been able to harness more power out of the answers.
Yes.
And I think that's where maybe so-called traditional investigative methods, you're maybe going in the opposite approach. But what we've learned and what we are learning is trying to keep that kind of a baser logic. And I think starting to realize some of those, some of the power and some of those rewards.
You're right on the money. So logic comes out of an old root cause analysis method called Apollo. And Apollo still has a software program that they sell called Reliance. And in Reliance, you are not able to type more than 2 words in any box. I'm glad that Logic or that CauseLink is not that restrictive, because sometimes I want to choose to tell a little bit of a story in a box. But really, I mean, now that you kind of see that link, that simple equals good, like you can have the same word count, but do it with more boxes, because that's more granularity, that's more clear understanding of where causality is actually happening. You really try to limit yourself to just 2 words. Like you probably won't do it, right? Like I will say most of our charts, very few of them have any boxes with only 2 words, but we always apply pressure to how do you say this with fewer words? And really try to get a verb noun pair. Bolt broke. What caused the bolt to break? Force applied, right? What caused force to get applied? Pallet fell. What caused the pallet to fall? Forklift hit. What caused the forklift to hit it? Operator sleeping. It's like, oh crap, that's why our bolt broke.
So do we have any other questions for Joseph? Nope. Okay.
Yeah, my apologies for the technical difficulties and my apologies for not being able to show you. I will just say I did not write this presentation, did not prepare to explain with word pictures how a cause and effect diagram works. It's actually like a pretty key part of my presentation to build one with you. If you have any questions, like shoot me an email, but definitely go to CauseLink and check it out. They have a lot of great examples. You'll be able to see what it looks like.
Great. Okay, I want to thank everybody who attended tonight, and I appreciate everybody's patience. And Joseph, I really appreciate your willingness to present to us, and we look forward to, I'm sure we'll be talking to you about some other things. So just want to thank everybody tonight. So I will end our session, and everybody have a good evening.
Thank you so much.
All right, bye-bye.
Bye.